morning, afternoon, or evening. How y'all doing today? Welcome back to Moro's Math Corner. Today we're going to learn how to solve systems with three equations in three variables. Now you can use either the elimination or substitution methods to solve a system of three equations in three variables by working with the equations in pairs. I'm going to show you what that means. You will use one of the equations twice. And when one point represents a solution of a system of equations in three variables, you're going to write it as an ordered triple. That's right, because you're going to be using the x, the y, and the z. Now, just a little side note. We all know that the x and y axis are as such. The x is horizontal, the y is vertical. The z, my drawing doesn't do justice because it's two-dimensional, but the z is actually a third dimension. So when you have that ordered triple, it's not only the two dimensions of length and width, but it's also depth, the third dimension. All right, so now, how do we solve? Well, right off the bat, the easiest way is elimination. When you see a system of three variables or three different equations, you want to go ahead and first pair the first two equations of the systems and solve for one variable by elimination. Once you do that, you're going to have an equation with two variables. So you're literally going to take these first two, and in this particular case, the z is the easiest one to solve for. Sometimes it's nice and easy like that. Sometimes you got to manipulate the equations. But these z's go bye-bye. I've got 3x plus 2y equals 15. Let's hold that there. Next step, number 2. You're going to take the second and the third equations, and once again, you're going to solve, but this time you have to eliminate the same variable that you eliminated in the first step. So that means that in this case, I'm going to multiply this top equation by a -1 to give me -x minus 3y plus z equals -11 plus the 4x plus y minus z equals 14. The z's now can cancel, and that has to happen. So I have 3x minus 2y equals 3. So now I'm going to take these two equations, you're going to use the two variable systems that you created and solve for both unknown variables. So you're going to take these two over here and you're going to go ahead and solve. Now, you may say, wait a second, Mr. Moore, you made a mistake. You have 3x minus 2y equals 3, but over here you have negative 3x. That's right, I went ahead and I divided both sides by a -1. So that way I can set up my system to eliminate the x's right off the bat. So y equals 3. If I know y, I can plug it into either of the equations that I created here for step 3. So I'm going to go 3x plus 2 times 3 is 6 equals 15. We got 3x equals 9. And you've got x equals 3. Now that I have the x and the y, I can plug that x and y into any of the x and y's of the original equations given and solve for z. So I'm going to go ahead and plug my x and y into here. So I've got 3 times 2, which is 6, minus 3, plus z equals 4. That's 3 plus z equals 4. Subtract the 3, and z equals 1. So my ordered triple here is 3, 3, 1. And yes, just in case you are wondering, you can check these. So let's check them. 3 times 2 is 6, minus 3, plus 1. That's 3 plus 1 is 4, it works. 3 plus 3 times 3 is 9, minus 1, that's 12, minus 1 is 11, it works. 3 times 4 is 12, plus 3 is 15, minus 1 is 14, it works, and that is my solution. All right, let's try another one. Okay, let's solve this system. Let's go ahead and take the first two together. And I want to eliminate one variable. For me, the easiest variable in this particular case to eliminate is the y. So when I add these, I'm going to have 2x plus 4z equals negative 4. Then I'm going to take the second and third equations. And once again, I have to eliminate the y here, because whatever you do to the first step, you must eliminate that same variable. So when I add these, I've got 3x plus 5z equals negative 3. So now I'm going to take both of these and set up a system and choose which variable I want to eliminate. And me personally, I am going to choose to eliminate the x's. So I'm going to multiply this by a 3 and this by a negative 2, giving me 6x plus 12z equals negative 12. Negative 6x minus 10z equals positive 6. The x's cancel. I've got 2z equals negative 6 divided by 2, z equals negative 3. Now that I have that z equals negative 3, let's find my x. 3x minus 15 equals negative 3. 3x equals 12. X equals 4. And now I have that x equals 4, z equals negative 3. So I'm going to plug it into this first one and solve for y. So I've got 4 minus y minus 3 equals negative 1. That's 1 minus y equals negative 1. Subtract the 1. Divide by a negative 1. And y equals 2. So my solution is 4, 2, and negative 3. And yes, you can and should check them. So let's check them. It's not that difficult. We've got 4 minus 2 minus 3 is negative 5 plus 4 is negative 1. Yes. We got 4 plus 2 is 6 minus 9 is negative 3. Yes. 2 times 4 is 8 minus 2 is 6. Minus 6 is 0. Yes, it works. All right, next skill, substitution. Sometimes you can use substitution to solve a system of 3 equations. This method is used when you can easily solve for one of the equations for a single variable. So when you scan these 3 equations, you should notice that I can go ahead and solve easily for x here. So that's what I'm going to do in my first step. I'm going to solve for x. So x equals negative 5y plus 9. Now step 2. I'm going to take the value of that x and I'm literally going to plug it into the x of the other 2 equations. As so. Look at example 3 here for the completed value. What I did here was 2 times x, which is negative 5y plus 9, plus 3y minus 2z equals negative 1. Distribute. Add like terms. So we've got 7y, negative 7y, minus 2z, subtract the 18, equals negative 19. Bingo. And in the second one, we've got 4z minus 5 times x, which is negative 5y plus 9, equals 4. So I've got 4z plus 25y minus 45 equals 4. So I'm going to go ahead and add the 45 over here. And then I have my 4z plus 25y equals 49. Okay, so that's how I got this one. And that's how I got the second one. Now that I have my system of two equations, I'm going to go ahead and eliminate one of the variables. Me personally, I'm going to choose to eliminate the z. So I'm going to multiply a positive 2 up here to the top equation, giving me negative 14y minus 4z equals negative 38. This has been calculated, so I have 11y equals 11, y equals 1. Now that I have my y, I can go ahead and plug that into the 7y minus 2z equals negative 19 equation and solve for z. So I have negative 7 minus 2z equals negative 19. Add the 7. Negative 2z equals negative 12. Divide by negative 2. Z equals 6. And now I have y. Now I have z. I can go back to my original equation of x equals negative 5y plus 9. Plug in my y. And x equals 4. So my solutions would be 4, 1, 6. Let's check it. Okay, 8 plus 3 is 11 minus 12. Yes. 4 plus 5 is 9. Yes. And then 24 minus 20 is 4. Yes, it works. All right, let's try another one. Try substitution here. If you notice this second equation, I can go ahead and solve for x quite simply. So x equals negative 5z minus 12. Go ahead and plug that x into the x of the other two equations. So I have negative 5z minus 12 minus 2y plus z equals negative 6. So that's going to be negative 4z minus 2y equals positive 6. And then, let's plug it into this one. Got a negative 5z minus 12 plus 6y plus 4z equals 3. This is 5z plus 12 plus 6y plus 4z equals 3. Combine like terms, 9z plus 6y, subtract the 12 equals negative 9. Now let's go ahead and combine these two. So I've got negative 4z minus 2y equals 6, and 9z plus 6y equals negative 9. I'm going to choose to eliminate the y, so I'm going to multiply this top one by 3, giving me negative 12z minus 6y equals 18. The y's cancel. Negative 3z equals 9. Divided by negative 3. Z equals negative 3. I can go ahead and plug that back into my x equals equation. It's going to be 15 minus 12, which equals 3. So x is positive 3. And then I can plug in the x and the z into, let's say, this top equation to find my y. So I've got x, which is 3, minus 2y, plus z, which is a negative 3, so that's minus 3, equals negative 6. The 3 and the negative 3 cancel, divide by negative 2, and y equals 3. So my solution for this problem would be 3, 3, negative 3, but let's check it, because we can always make errors. So let's make sure we didn't. So I've got 3 minus 6 minus 3, that's negative 6, yes. I've got 3 minus 15, that does equal negative 12. And I've got negative 3 plus 18, which is 15. 15 minus 12 is 3, perfection. And last but not least, let me show you how to set this up in a word problem. When you're reading each sentence, they're giving you an equation. Write the equations and label. The sum of the digits of a 3-digit number is 12. So right off the bat, I've got x plus y plus z equals 12. Because the sum of each of the 3 digits is equal to 12. The tens digit is 2 less than the hundreds digit. So if this is my number comprised x, y, z, this is my tens, this is my ones, tens, and this is my hundreds. So they're saying that the tens digit, which is y, is 2 less than the hundreds digit, which is x. So that's x minus 2. And the third sentence, the ones digit, which is z, is 4 less than the sum of the other 2 digits. So that's x plus y minus 4. And there you have it. Now you created the system. Now let's go ahead and plug. Me personally, I'm going to use substitution. Because I have a y here that I can just plug in easily. So yeah, that's exactly what I'm going to do. And actually, yeah. Okay, so I have here that y equals x minus 2. So I'm going to go x plus y, which is x minus 2, plus z equals 12, which is 2x plus z equals 14. And I'm also going to plug that x into that y into this y over here, giving me z equals x plus x minus 2 minus 4. So that's going to be 2x, which I'm going to bring over to the other side, negative 2x plus z equals negative 6. Now I'm going to take these two equations, and the logical step here is to eliminate the x's. So the x's will cancel. I've got 2z equals 8 divided by 2. Z equals 4. That's my ones digit. Now I know that z, which is 4. Okay, so I got z is 4. So now I can plug it in and find my x. Negative 2x plus 4 equals negative 6. Subtract the 4 to both sides. Negative 2x equals negative 10. x equals 5. And now I have my x and my z, so y equals 5 minus 2, y equals 3, and my solution is going to be 5, 3, 4. So the number is 534. And there you have it. And 5 plus 3 plus 4 is 12. It works. Y is the second term, so 3 does equal 5 minus 2. It works. And z is 4. That equals 5 plus 3, which is 8 minus 4. It works. Hope this helped a lot. Hope it wasn't that bad. Thank you so very much. Have a great day. Come back anytime. Take care now. Bye-bye.